Hello, I'm Mickey Granot, and you are welcome to yet another session in our Introduction to Theory of Constraints education series. This time we will be focusing on production, the theory of constraints way, how to get more, faster, and more reliable from your production, and then even become better. Some kind of agreement on the type of manufacturing this specific video session is going to be focused on. The production environments we will be talking about are typified by having multiple resources involved in the process of converting raw materials into finished good. The total processing time of a standard production batch is less than 10% of the total lead time of the batch. So we're not talking about industries where the time that it takes to process a part or a finished good is by far greater than that. And the flow between production steps is discrete. So right now we will not be discussing continuous flow type of production environments. The same solution with the appropriate modifications, of course, will apply to the other type of production environments as well, but we will discuss them in separate sessions where we'll dedicate some thought into that specific characteristics of those industries. Still, most of the industry is pretty much following or adhering to these three criteria just stipulated. What is the purpose of managing production? Production needs to do simple tasks to deliver all orders to customers as promised on time, in full quantity and quality, and do it in a cost-effective way. And over and above that, ever become better to improve the competitiveness of the company as a whole and its ability to make money out of that business as well. So it's simple, however, how we go about it. What do we need to do, or what do I do? And is it the right way to do it, and what is the alternative? So talking about what do we do and how do we do it, we need to talk about how we measure it. So there is a list of probable existing measurements of performance in production: the supply time, the production lead time, the reliability of supply, resource efficiency, work in process, cost, etc. This list is almost comprehensive. When we have many measurements, it is important to define a key performance measure. The key performance measure is a measure that indicates for everyone that, yes, we expect you as management to be good on all measures, but we understand reality has surprises, things you do not expect. Things do happen, and when it is impossible to deliver to all of the measurements, the key performance indicator is more important than the other. Commonly, in the production world, the key performance measure is resource efficiency. It must be that we believe that if all resources are very efficient, and there is a lot of effort today in implementing a concept called OEE, overall equipment efficiency, if you would like, trying to make sure that we utilize our resources as highly as possible, we must assume that if we do that, our ability to deliver on time, in full, to our customer orders, and then improve is served by measuring this measure in the best way. Is this really the case? Let's understand what must happen in order to have a resource being efficient. Resources cannot be efficient if they have nothing to work on. Therefore, production management is trying to ensure there is enough work to fill up the available time of our resources. How do we do that? One, our production planning is very detailed. Every part, every step of the process has a schedule of activities for every day of every time of the day what they are supposed to be working on so that they do not waste time not producing. More than that, over and above that, we also introduce rules that are designed to keep our resources occupied. Rules like minimal batch sizes, producing to forecast when we don't have orders, balancing the load so all resources are occupied in a very similar way. And the question is, how well is it working for us? So when we measure as key performance indicator efficiency, every work setter by definition will try to maximize their efficiency. So production planning and control would like to have as accurate plan as possible. Actually, sometimes I've been working with a factory that was having a plan in intervals of 8 minutes per resources. So this is maybe an extreme, but we are trying to have a very accurate plan. And just a few examples. If you want to maximize efficiency, then work centers will prefer to produce items that require minimal or no changeover from their queue. So if I have a queue of orders waiting, when I finish one order, I will look at my queue and I will prefer to pick the next order that requires as little as possible changeover from the one I just did. We produce to inventory even if we do not have orders right now, so resources will not stand idle. And work centers prefer to increase batches. For example, oftentimes we can give the first step in the process raw material, which is slightly larger than what is required because it is not always one-to-one. And the work center is getting an order to not consume all of the raw material. However, they will consume all of the raw material. As a result, there is much more work in process flying into the factory. When WIP is growing, lead time is elongating. When we produce more, we create more finished goods stocks we cannot sell. When we have more inventory, return on investment is lower. Our cost is higher because we actually pay money to produce products we currently do not need, in quantities we currently do not need. We buy them and we pay salaries and energy, etc. The productivity of every resource may be high, but the productivity of the factory is low. Our on-time in full performance deteriorates. Customer satisfaction is definitely negatively affected. And availability of finished goods is also deteriorating. Add to that uncertainty, and well, we are firefighting all day long. When our plan is very accurate in uncertainty, our production planning is constantly occupied in replanning. So resource efficiency, maybe it's not working that well for us. Let's try to understand if it makes sense at all to measure efficiency. Maybe we are just not using it correctly. So let's try to understand what needs to happen to keep a resource efficient 100% of the time. If a production flow is made out of few resources, discrete flow, every resource is doing his own part, and Murphy exists, and we want, let's say for the sake of our discussion, we have only one resource fully utilized. What must happen? What do we have to do? We must understand that because Murphy exists, because uncertainty exists, any one of the resources before the one we want to fully utilize, from time to time will not be able to operate because of Murphy. If it's not able to operate and we do not have a buffer between those resources and the one we want to fully utilize, the one we want to fully utilize will not be able to operate. Now assume that we do have a buffer in place. What happens? If Murphy will hit one of the three resources in front of our full utilized resource and the flow will stop, our full utilized resource will continue working by consuming from the buffer in front of it. If the buffer is correctly sized, then the inventory will not be depleted before we overcome Murphy. So when we come over Murphy, the resources which are in front of the resource fully utilized must perform two actions. They must feed our fully utilized resource, but at the same time, they must build up the inventory in front of it for the next time Murphy will hit. And when this buffer is full, they must up. So practically in every flow of resources, it is impossible to utilize to 100% more than one resource, as the other resources must stop in order to not build piles of inventory that no one can use. And inventory is lead time, and lead time elongated will deteriorate our performance. It's kind of a highway, right? Think about driving your car to work on the first day of the week at the peak hour of the morning versus driving the same exact road on a weekend at the same time. The only difference is how many cars are on the road. When there are many cars on the road, the time spent on the road increases, the productivity of the road decreases, i.e. less cars will be finishing the distance in the same period of time. So the same will happen in our production. What are the conclusions? Resources not working is not necessarily a waste. Actually, the contrary, when we activate, when we push to IOEE, we do create waste and we do create cost which is not required. If we want to avoid waste, when the safety stock is full, we must actively stop the other resources or slow them down. And the effort to keep all resources utilized not only does not help in realizing production goals, but actually prevents them from being realized. Efficiency and detailed planning must be abandoned. Let me just explain the concept of the bottleneck, because there's a lot of confusion out there. In any flow of physical goods, there will always be one and only one resource that is the slowest in the flow. By definition, slowest, right? Cannot be more than one slowest. This slow resource can be either a bottleneck, and it will be called a bottleneck if its capacity is insufficient for producing all the demand placed on it, or it can be called a capacity constraint resource when its capacity is greater than the demand planned of it, but it is still the slowest resource in the flow. When it is a bottleneck, it will also be the constraint of the system, because its capacity dictates how much money the flow can generate. Otherwise, it is not the constraint. The constraint will be elsewhere. Most production environments practically do not have a bottleneck. However, most of them are under the impression they do have a bottleneck, or even more than one bottleneck, which is primarily a result of the quest for efficiency, which is loading our resources unnecessarily. The theory of constraint solution to that is called Drum-Buffer-Rope, and the advanced feature is called Simplified Drum-Buffer-Rope. And then there's three key components: the drum, which is a production planning mechanism; the buffer, which is a protection mechanism against Murphy; and the rope, which is a mechanism to ensure that we do not allow too many cars to enter the highway. Applying these mechanisms depends on the type of production environment. There are two types of production environment. Interesting: the make-to-order environment, where production does not produce unless it has an order from the customer, or the make-to-stock environment, where production produces to stock and customer is consuming from available stock. There are, of course, environments where the situation is hybrid. There is make-to-order and make-to-stock. There is no other type of production environment. So how do we apply simplified drum-buffer-rope when we assume there is no bottleneck in each one of those environments? In make-to-order, the drum is actually the schedule of order delivery to customers. What we promise to deliver to the market sets the pace at which the production should work. The buffer is a set time before that due date promised to the customer, in which we want to start producing the order. This buffer should be sufficient to absorb Murphy. There are rules how to do it, and when we'll go deeper in one of the future sessions, we will discuss how to define this buffer. And thirdly, there is a rope. The rope is a rule. The rule is never start processing an order before the calculated time, even if you have capacity and resources are standing idle. In make-to-stock environment, the drum is set by consumption from the inventory, The buffer is the inventory itself, and the rope is again a rule saying never produce unless the inventory in the buffer indicates there is a need to produce. All buffers are following the same structure. They are different. In the make to order, the buffer is time. In make to stock, the buffer is stock. But they follow the same logic. They are split into 3 zones. The first 1/3 of the zone is green. The second is yellow. The third is red. And there are 2 key benefits coming out of it. The first one is a clear priority system for everyone. Everyone knows that the order on the floor, which is colored red, is of a higher priority than an order colored yellow or green. It is directly related to the service of the customer, either the due date promised or the inventory needed to ensure that we can service the market. So red is higher importance than green, yellow higher importance than green, clear priority for production and supporting function as well, like quality control or maintenance. And it also serves as an indicator to trigger the focus the continuous improvement effort. So every time a buffer turns to red, we document the event, and once a time these events are analyzed and entered into our lean initiative to make sure we make the utmost out of it. If applicable, because we started applying the solution assuming there is no bottleneck, if there is a bottleneck, the red events will happen continuously in that location, and very quickly we will identify there is a real bottleneck and we'll be able to focus on removing it. So this is how we get not only the better performance, but the continuous improvement of that. What can we expect? A significant reduction in production lead time, at least 50% reduction of lead time. We almost perfect reliability of supply, 98% plus is norm. 30 to 50% reduction in inventories, finished good inventories, work in process is at least 50%, and meaningful increase in productivity, at least 25%, oftentimes much more than that. So production flow is like a highway. Too many cars result with longer stay time on the road, lower productivity, and increase in cost. The way to improve production is by aligning the release of material and production orders with the actual demand. Have visible buffers that indicate priority, and have a good mechanism that guide and focus the continuous improvement effort. Simplified Drum-Buffer-Rope provides this mechanism effectively, rapidly, and with extraordinary effect on production and business critical performance measures. Thank you for being with us today, and bye-bye.